The U.S. Postal Service will accept a box for domestic shipment only if the sum of its length and girth does not exceed 108 inches. What dimensions will give a box with a square end the largest volume possible? So, in order to avoid conflicts with the uploading of the video, I've already drawn the diagram and solved the problem, but I'll be explaining each of the steps. So, since this involves volume, the first equation we're going to be using is a volume equation, which is the length times the width times the height. Since this box, the face of this box is a square, that means each of the sides is equal to one another. So we can replace the length and the width, or the width and the height, with x, and the length itself with y. So it would be x times y. Simplified would be x squared times y. Now, the problem stated that the length and the girth of the box cannot exceed 108 inches. The girth is defined as the distance around the object. So since this is a square, each of the sides is equal, so we can set that as 4x, and the length will be considered as y, and set it equal to 108. Rewriting that as y equals 108 minus 4x. We can then use this equation that we rewrote for y and substitute it into the equation for volume, and that would be equal to x squared times 108 minus 4x. Once we do that, we can take the first derivative of this, and in order to find the critical points, so all this being simplifies to negative 12x squared plus 216x, which then can further reduce to 12x times 18 minus x. And with this being said, the critical points of this first derivative are 0 and 18, but since 18 is the only possible critical point, since 0 cannot be, otherwise the box wouldn't exist. Once we do this, we can take the second derivative, which is equal to 216 minus 24x, and substitute in 18 for x, which comes out to be negative 216. Now given that the second derivative is equal to negative 216, this is less than 0, which concludes that this is an absolute maximum. Therefore, our x, which is our width and our height of the box, is equal to 18 inches. Now that we have the width and the height, we can substitute this into our original equation of y equals 108 minus 4x in order to find the y segment of our box, which is the length. That is equal to 36 inches, which gives our box a total volume of 11,664 inches cubed.